Hello, my name is Nur Khairunhazwani Binti Zamri. My metric number is 199246. I'm a final year student of Bachelor Agriculture and Biosystem Engineering. I would like to present my final year project entitled Conceptual Design of a Platform with two axis positioning system for vertical green farming. So this is the outline of the presentation. So I continue the presentation with background of the study. Vertical farming has been suggested as an engineered solution to increase crop productivity by growing plants in vertical spaces, thereby increasing land use efficiency for crop production. In this study, I propose a design of a platform for vertical farming using two-axis positioning system that applied coaxial mechanism. Coaxial is type of Cartesian motor system that use two stationary motor to move the carriage in vertical and horizontal directions. Next, the problem statement of this study. The structure of vertical farming is very tall as some plant cannot be easily harvested. The problem is to position the robotic arm with minimal mass and inertia for a long traveling distance such as within 5 to 6 meters with vertical and horizontal direction. Then, to utilize the coaxial concept, whereas the motors used to control the movement in horizontal and vertical direction were placed stationary on the ground. The main objective of the study is to prepare the conceptual design of a framework that support the movement of a robotic arm in horizontal and vertical direction for an indoor vertical farm setup. The first specific objective of the study is to propose a design concept of a platform with two axis positioning system for a vertical and horizontal movement. Second is to develop a virtual 3D model in CAD of the proposed design concept. Next, we move to the scope and limitation. The distance is based on the conceptual ideas, whereas selection of the component needs to be further refined, and also the component positioning configuration should be based on the coaxial mechanism. Second, the deflection of the vertical and horizontal platform should be analyzed using finite element analysis, and then the 3D model was developed. Next, the selection of the motor must be proved with the calculations of storm, initial power, and the efficiency of the motor. So we move to the methods and method of the study. First, for the project flow, I need to analyze the problem and set the objective, and I need to design the purpose. I need to propose the design of this platform in the sketching, and the design of the platform should be analyzed using menu calculation and the finite element analysis. And for these studies, we'll come up with the 3D model, the drawing, and the build of the material. So the software used for this project is Autodesk Inventor 2021, used to develop a 3D model of this platform, and use finite element analysis in this software to determine the deflection of the vertical and horizontal beams. Next, identify the important component used in two-axis positioning system by applying coaxial mechanism. I propose the 24-volt DC motor, 10 set of timing pulley, 2 long of timing belt, open linear bearing, and open linear railing. So I need to determine the component positioning configuration by applying coaxial mechanism, which consists of 2 stationary motor, 2 motor pulley and X support pulley, and 2 long timing belt. This movement of the platform will controlled by the 2 stationary motor. When the both motor rotate in same direction, we will perform the motion left to right, and when the both motor rotate in opposite direction, we will perform the motion upward and downward. Next, we need to determine the motor sizing. In this proposed design, 24-volt DC motor used to turn the pulley and to transmit the power from the electric motor to move the carriage of the robotic arm. Then the input and the output power of the 24-volt DC motor was determined in order to ensure the proper selection of the motor. Next, for the result on of this study, I come up with the first idea of design of the platform, which is some problem was identified, which is double stack pulley more suitable to lift lighter load and no concept to place the platform. Then I come up with the second idea, which have a casing of to place the component and the position of the component based on the coaxial mechanism. Then design analysis on horizontal and vertical motion framework. Next, analysis for horizontal beam using circular tubing. At first, I propose a circular tubing as a design for horizontal beam. So when load 588.6 Newton was applied, the deflection is 1341 mm and very large and fracture will occur. So for the design, I improved the design of the horizontal beam by using truss system, and I propose the 2 types of tubing, circular tubing and square tubing, and I choose square tubing because the mass is lower than the circular tubing. Next, analysis on the improved truss design. Then the design of the horizontal wheel was improved by purpose for condition. For condition was developed by varying the value of the parameters A, B, C, and the angle to reduce the deflection gap of the horizontal wheel. So the condition for was selected because the deflection is lower than the other conditions. So this is the analysis to determine the deflection when load applied using finite element analysis in Autodesk Inventor for condition 1, condition 2, condition 3, and condition 4. So this is analysis for vertical beam analysis. So in this design, I propose 2 columns with the dimension 250 mm times 250 mm and 3 mm thickness. So when the load applied, the deflection is 3.41 mm with the factor of safety is 4. So next, determination of the motor required. In this design, I propose 24-volt DC motor, and the load that may carry by the motor is 15 kg. So the input power of the motor is 641.992 watts, and the output power is 544.39 watts. So I think the 24-volt DC motor is suitable for this design, since the 24-volt DC motor can supply power from 100 watt to 750 watts. So next we move to the virtual CAD model. So this is the full assembly of the platform by using coaxial mechanism. So the first figure shows the 2 long timing belt connected to the motor pulley used to transmit motor from the electric motor to move the carriage of the robotic arm. And then the robotic arm carriage will attach to the open linear bearing that will set on the horizontal linear bearing to move the right and left or distant 5 meter thrust beams. Next, this is show the horizontal platform that moves upward and downward using vertical linear railing. The linear railing was mounted to the vertical linear railing to move upward and downward, and rectangular mycene plate was attached to the linear bearing, and the 6 meter vertical linear bearing was mounted to the column that used to support the horizontal railing. So this is the column that used to place all the components, such as pulley, this is motor, linear bearing, and belt. So this is the drawing, some of the detailed drawing of the platform. Next is the build of the material that presented in this framework. The BRMs indicate the part that should be fabricated and purchased to make the final product, and some of the product can be purchased in the market, and some of the design of the framework should be custom made. So the total cost to fabricate this platform is 5,327 ringgit. So the impact of a platform with processing for vertical sound for society is this platform was designed to reduce human effort in practicing growing crop using vertical structure, as this design with 6 meter high and 5 meter long was traveling distance. Thus, they will make an easy solution for hydrating soil structure for vertical farming system. As a conclusion, the design concept of the 2-axis point system was vertical and horizontal movement has been proposed by applying coaxial mechanism. This proposed design concept was further analyzed with finite element analysis to determine the stress analysis and deformation on horizontal and vertical platform when load applied. So the final idea of the proposed design concept was demonstrated into 3D model in Autodesk Inventor detailed drawing, and the build of the material was developed. So for the recommendation of the project, the weight of the horizontal should be reduced to develop more lightweight platform and reduce the cost to fabricate this platform by reducing the use of steel to develop the structure. And the analysis of the proposed design of the platform can be further defined on other components such as pulley, belting system, bolt, and nuts to make it more comprehensive on this design. So recommendation for this platform was very useful as can help to address the farm workers' labor shortage and replace repetitive workload. This design of a platform helps the robotic arm to do repetitive tasks, and nowadays our farmers are increasingly relying on the robot to do their repetitive work and to solve their problem of labor shortage. Thus, the idea of the design should be further refined to implement in the future for our society. And thank you.